this is my super duper awesome drawing app that you'll be able to create after this. I'm going to walk you through every step, how to make your own. And yes, the app has some incredible features. That's random, the text is all puffy. Etched makes it look well etched, and original is the dots that you start off drawing with. I'm going to show you step by step how to make your own. Actually, you're going to make one even better than mine. I'm walking through each step of this lesson. It is tricky at times, at least I thought so, and I will go through every part of it to make sure we both, or you and I, create an awesome application. I am going to share my own, right? This will be shared. I share it towards the end of the video. It's probably in the description right now. Check it out. Look at the code while I'm walking you through it. Do not just copy my code, right? Plagiarism and things like that. Your teacher can find this super easy video as well if you can. So make sure to create it yourself, but I am here to help, and so is the code. So take a peek at it and get ready to start building something awesome. And when you're all done, you should definitely comment and share what you built below the video. I want to check out all the features that you added that I did not. Yeah, make something better than I did. Well, I'm not sure. Mine's pretty awesome. But let's go ahead and get started. Here we are, lesson 17, part 2. Part 1 was just kind of general info, and let's get started building our app. Introducing Canvas. Today we're going to be building a drawing app around a new UI element called Canvas. Sounds good? I'll pull this down a bit. And it's showing you how we can add a canvas, which it's going to ask us to do. A canvas is simply a transparent rectangle on which you can draw basic shapes like lines and rectangles. Yep, starter code is provided, which places buttons on the bottom of your screen. Yes, we got those. In design mode, drag the canvas element. Here we are. And I'm going to just place it up at the top like they did in that picture. But how did theirs look? Okay, I'm going to do it kind of like they did. I think they gave it a bit more. Yep, alright, that looks good. And perfect. Yep, so call set canvas. Oh, wait. In design mode element into an empty space. Yep. Resize it and give it a descriptive ID. Canvas area? Sure, canvas area. Call set active canvas with the ID you assign to your canvas, which makes it responsive to canvas commands. Set active canvas. So we're going to go over to our code and then canvas. Add a giant circle to the canvas. Use the circle command. Okay, so we got that. The circle command. 240, 200. I'm going to make mine like theirs. But giant circle. Your code will look like this. Perfect. Awesome. So that's our first step. We got us a canvas. Let's keep going. Alright, here we are. Loop on the canvas. Yes. To make things more interesting, we're going to quickly add 200 dots to our canvas by using a for loop. Locations on the canvas are relative to the top left corner of the canvas, not the screen. There, you will need to know the dimensions of your canvas in order to randomly place dots throughout it. You can find this information in design mode. Yep, you can. Click on design and gotta click my canvas. So my width is 310 and then my height is 385, which I want to be theirs. Yours doesn't need to be exact. Just be easier for me doing a tutorial. Do this, add a for loop, and remember that's one of those things that repeats, that runs 200 times. I'm going to switch to block mode real quick, and then control, and here's my for loop, and I'm just going to drop it in. Now my for loop right now only runs 4 times, because it starts at 0, and I goes up by 1 each time. You can think of I plus plus as I plus 1, okay? So it starts at 0, and it runs the code inside of it, and then goes back up to the top. 0 plus 1, I plus 1 is 1 now, goes through, goes back to the top, so I is now 1. Well, now I is 2. 2 is less than 4, drops back through, runs the code, goes back to the top. It was 2. 2 plus 1 is 3. 3 is less than 4, drops in, runs the code, hits here, back to the top. 3 plus 4 is 4. 4 is not less than 4, and it stops. So this, I think, will do 4 right now. Now, use a random number to randomize x and y. Okay. Oh, right. So we want 200. I'm going to start with 4 to show you what this is. We want to change the size, and if you're not sure which one is size on our circle over there, we can always look at it. It's going to be the radius, right? So the radius is the last one, and there's info right there. You could also click see examples. And then if you test your code before setting x and y, got it. And so for x and y, we need random numbers. So we're going to math, random, and then because we're going to randomize the placement of our circle, right? Random number to randomize x and y values as we're placing our more than one circle. Oops. Not math.random, random number. Random number. And then mine was 0 for x, and then 310, I believe, was my max. Let's double check. Width was, yep, 310, which will be x. 380, which will be y. Great. I think this should only draw 4. Let's try. Ta-da! Now they want 200. Ready for a lot of circles. Ta-da! Ta-da! More circles. Now, if you want to see it actually drawn, I can slow it down. And so it's going to iterate through 200 times. Starting at 0, it goes to 199, and when it hits 200, it goes below. But since we start at 0, 0 to 199 is 200 times. Awesome. Next up, what do we got here? Do we add color yet? Oh, no, not, well, kind of. All right, changing colors in Canvas. We would like to make our dots transparent, so you can see when they are drawn on top of each other. To set color and transparency of shapes, you draw on your canvas. You need to change both the stroke or outline color of and the fill color. The functions set stroke color and set fill color can be used to set those colors. These functions accept strings. This is a string, right? Anything in quotes like this, that's a string in code. And you always want to put quotes around a string unless you're dealing with a variable that equals a string. These functions accept strings of the form this as an input, or just like red in quotes. The first 3 values in the string are R, red, G, green, B, blue values, and the last value is the transparency, as represented by a decimal number between 0 and 1. 1 is solid, 0 is see-through. Altogether, it looks like this. Do this. Add a set stroke color, so stroke is the outline only, command to set the stroke to fully transparent. Okay. So stroke just means outline, right, like a pen stroke, and they want that to be fully transparent. So they want no outline on our, this is being grumpy. I'm going to go to showbox. They want no outline on our circles. So set stroke color, I'm going to need it above circle for it to work, because we got to tell the canvas we don't want a stroke before it draws it, before the code draws it. And then our color, just like they did up there, RGBA 0, 0, 0, and then we want 0. So no color, and the last one is fully transparent. So our circles should no longer have an outline. Add a set fill color command to set your dots to full black and mostly transparent. Try 0.2. Alright, so fill is the inside part of them. Let's see here. Set fill color. And same thing here. RGB A 0, 0, 0, 0.2. And in parentheses, I put spaces just to make it more clear, but I don't need to. Alright, let's see what it does. Ta-da! Ta-da! Alright, so I think we got, and again, I can always slow this down if you want to see. Think you get the point? We're going to keep going. Let's see. 4, goodbye 4. Alright, part 5. Click to add dots. Loops are one way of quickly adding dots to our canvas. But now we're going to change our app so that the user can decide when and how to draw the dots. The canvas is a UI element, user interface that means. So you can attach event handlers to it just like you would any other element. We're going to move the circle command inside the click event handler so that the user can click to add individual dots, right? So we're going to only allow it to add dots upon click, upon an event handler, right? And the event that we're handling, or we're going to be watching, mine has the idea of, I'm pointing at the computer screen like you could see it, ID of canvas area. I'm going to be watching that with my event handler, listening for clicks. So on event, I'm going to move to code. I just find it easier to read, especially in videos. Okay, so I'm going to put this down here because I'm going to move all of it, right? Loops. Perfect. Yep. So I'm going to grab circle because I want the circle still. I also want this code. We don't need the loop anymore. Bye, loop. Okay, so now at the top, I'm going to set canvas area to active, set the color, and set the color again, and then I'm going to be listening to ID, which is not a thing. I'm going to be looking at canvas area, listening for a click, and if there is a click, I'm going to just draw this. Let's give it... Oh wait, am I deleting random? Nope. Alright, let's try. Look at the circles! I'm clicking, by the way. Cool. We got it. Awesome. Onward. The event parameter for mouse events. We'd like to change the app so that the user clicks on the canvas we draw, so that when the user clicks on the canvas, we draw a circle right where they clicked. That would make more sense. To do that, we need to learn more about the parameter passed by our event handler function, which by default is called event. So by parameter, they mean this, whatever goes in this, right? What's being passed. Recall that we wanted to know what key the user pressed on a key press event. We check the value stored in event key. The event parameter actually stores a great deal more information about each event. When using the mouse, the event parameter carries information like the location of the mouse, how fast it's moving, and some other things as well. Let's get acquainted with the event parameter and what we can find out about the mouse. Do this. Add a console.log command inside the function of your event handler, okay? Use it to display, the event parameter. All right. I think box is a bit easier. I'm going to add my console log. And to display event, I'm just going to have the word event. No cat quotes or anything like that. Run your program and click on the canvas. The full contents of the event parameter should be displayed in your console, and that should be down here. Ta-da! Whoops. That's better. Not sure what happened to my event there. So, now I have event there, and we got a ton of info. You can see it goes on forever. Mouse value, mouse X, mouse Y, all sorts of stuff. All right, let's see what we can do with that now. Do make sure, though, to highlight, you want to have event here. It's a parameter. So you need to have event here as your parameter. Once we have this as a parameter, all right, let's keep going. 7, all right. Drawing dots at click. Currently, the user can click to add dots, but they're drawn at random locations around the canvas. We're going to use information stored in the event parameter of the event handle function to place dots wherever the user clicks the mouse on the canvas. Okay. The event parameter has two critical pieces of information we'll want, which are event.offsetX and event.offsetY. These hold the location relative to the top left corner of the canvas that was clicked. Remove or comment out the console log statement by console log. Replace the XY parameters of the circle command with event. Okay, so by XY parameters, that's where we have random. And we're going to use event.offsetX because that's going to be our X location of our mouse. And then Y, and make sure you're capitalizing the end of that, X and Y, to be the Y location of our mouse. So what this is going to do, hopefully, is that it's going to listen for a click on our canvas, and when we do click, it's going to get the mouse's X location right here through event, the mouse's Y location, and draw a circle where X and Y are. So right where we click, hopefully. Ta-da! And ours looks like theirs. Great. Let's keep going. Drawing on mouse move. Yes, great. Currently, the user can click to add dots, but we want to place dots whenever the user moves the mouse on the canvas. To place dots whenever the mouse is moved, we'll be changing the event type from click to mouse move. Change the event type in your event handler from click to mouse move. Click, mouse move. Run the program to confirm that dots are being drawn anywhere you move the mouse. Click. Awesome. Yep. Anywhere on the screen. What's theirs look like? Oh, they're holding it for longer. Alright, let's keep going. Draw when a key is pressed. This app now lets the user draw, but they have no control of whether the pen is up or down. Let's give the user the ability to choose when to put down the pen. We won't even need to add a new event handler to our app. You may have noticed the event parameter includes information about whether certain keys were pressed when the event fired. They are stored in variables with names like Shift key or Alt key and are stored as Boolean values true/false. And Boolean values are always only true and false, critical part of code. So what it's saying is if I'm holding down the Shift key, this is a Boolean value, so it would be true. The second I let go of the Shift key, this is false. Same with our Alt key. We are going to use the Shift key variable to decide when we draw circles. If it's a Boolean value, if statement's what you want to do, because if statements check for true and false. If event.shift key. So what this is saying is to the computer is the shift key down? If the computer says true, it's going to run the code inside the if statement. If the computer says false, no shift key down, it skips it and runs the stuff below. Add an if statement inside your event handler function where the condition is based on the value stored in the event.shift key. If the shift key is true, if it's being held down, draw the circle. Got it. Show blocks, we need control, we're going to use an if. So we still want to draw a circle, but we are only drawing a circle if, that's purple, event.shift no, I'm just typing it. Event dot shift key. Okay, we're checking if the shift key. Let's test this out. No shift. No, nothing. Shift is down. Ah! Alright, let me read their note. Note, if you wish to use console log to display the values, you'll see event shift. Yep, hold the shift key, release shift to stop drawing. Yep. Great, let's keep going. This is looking good so far. Alright, store your dots. Okay. Now we're going to get into the core of the activity. We will be creating a record of every dot the user draws. To do this, we'll append every event parameter to an array. Append means add to, so we're going to smash it against the end of it, as the events are generated. So as every single click occurs, we're going to make a big array to record all of those clicks. When we store every mouse location in an array, we make an interesting effect and redraw the image in different ways by looping over the array. First, let's just make sure we can capture them all. Create a new array outside the event handler function, variable event list. Alright, so this is going to go towards the top, right? You really want to put variables at, if not the top of your code, very close to the top. And they told us what to call it, so I'll call it that. Event listen. And an array, you need to have brackets after the equals. In your event handler, before you call the circle command, use append item to add the event parameter to event list. Alright. Okay, so we have this. We're going to add the item. If shift key, we got that. And there we use what we need, append item. And then what we're going to be appending, and append means smack on the end of it, basically. What we're pushing onto the end of it is our event list, comma. And let me just double check if that's what they did. Perfect. Run the program and draw some dots. In the debug console, console log event list and inspect the contents. Event list and inspect the contents. So what we're saying is, hey, get our event list and append event to it. Okay, oh, gotta hit shift, I believe. Cool. And so it's showing us all of this. Huh. It might be a lot. Yeah, it's a lot. Alright, let's keep going. We are finally, okay, so delete button. We are finally going to use those buttons. Each one will trigger an event handler that processes the array event list to create the visual effect with the mouse data you have stored. The first effect we are going to create is delete. Delete button. We are finally going to use those buttons. Woohoo! Each one will trigger an event handler that processes the array event list to create a visual effect with the mouse data you have stored. And what they're saying is, because we have this array event list, it's an array, and we are appending, right? Our append item every time is grabbing our array event list and grabbing the event that triggered it, us clicking down, and putting all of that information at the end of the event list. It adds a comma, and then it puts all the information from event, like the mouse's Y and X location, and buttons up and down, and all of that. And then we click down again or whatever, and it again triggers this event function, puts all of the new event at the end of the array. So it's a big list of every time, basically, we click and shift key and all of that. Not click, move the mouse around. All right, so we're going to use this stored info to do stuff. So to create a visual effect, the first effect we're going to create is delete. You may want to provide your user with a way to start over with their drawing. In order to do this, you will need to both clear the canvas and delete all items from the event list. The easiest way to delete everything from the list is to simply set the value of event list to a new empty list. Do this. In design mode, set the styling and text of one button to indicate its delete or start over button. What did they do? Oh, yeah. Give it a descriptive ID. All right, design. I'm going to pick the button they did. I'm going to call it, that's its ID, delete btn. The text is going to say delete. And the color will be something like that. All right. Yep. Add a click event handler to your button. Events, insert and show code. Okay, so here's my code down here. I don't need my console log. All right, but I have an event listener. On click, if I click that button, what do I need to do? Within the event handler called clear canvas. Okay. Set event list to an empty array. So we're basically just telling it to start over. So we've already declared that variable. We're not declaring another variable. We're just telling it the variable we have declared, right? There's no var in front of this. That will throw an error. Is going to be equal to an empty array, empty list. Set your test program to make sure that the starting over works the way it should. Okay. Oh, I wanted to get rid of that console log. Oh well. Ta-da! Ta-da! Cool. Let's keep going. We got, yeah. I'm not using an event, so I'm going to get rid of it there. All right, redraw random part 1. The next effect we're going to create is random. We will be redrawing the image, but with randomly sized dots. We'll be doing this in 2 steps. For now, all you need to do is change the first button in the row to have the proper styling and attach a click handler to it. In addition, clear the canvas from inside the event handler. So we are ready to redraw our image. We don't want to delete all items from the array though, as we will use them to redraw. Once you've done that, move on to the next exercise where you will write the actual code in our event handler. All right, so change the first button in the row to have proper styling and attach a click handler. Do this. In design mode, pick a button to use for random. Set the styling, Set the styling in the text of that button. The image below shows one possible option, but you can style it how you like. Give it a descriptive ID. Oh, that's the text. And then btn for my descriptive ID. Color-wise, I was thinking of more along the lines of that, maybe? Sure. And then event handler, click event handlers. So now I add an event handler, right? Here's my event handler. Event handler, I don't need a console log. I'm going to get rid of my old console log from this because it's driving me nuts. This is just my console log from the event list thing. Call clear canvas from inside the event handler so the canvas is ready to redraw. All right, so canvas clear. And that's it for this one. All right, bye. Oops. And ta-da, clears our canvas. Let's keep going. Redraw random part 2. Now you're ready to rewrite the code for our random effect. To do this, we will be clearing the canvas, then processing the array. And an array is a list of data, right? And what's in our list of data? What's in our array? It's all of the events. An event is triggered whenever we do something on the canvas. That's when it's going to happen, right? See event as this parameter. So when I do anything on this canvas, an event is triggered. What that means, and then we grab that event and append it, put it on the back of our array event list. So the mouse's X value, Y value, what keys are up and down, all of that information is put onto this humongous list of info about what we've done on our canvas. Every time a dot is drawn, there's something added to this list so the computer tracks everything we've done so it can redraw and change things. That's what they're talking about with our array event list. That's the info about every dot we've drawn. And then this append item is the thing that's making that big list as we're drawing by moving the mouse around. All right, you ready to clear your canvas? So we'll need to process our array in order to find out the event information for each dot. You'll need to create a for loop that iterates through every index in the event list. Recall the length command. Within your loop, you will be drawing dots referencing items stored in that array. Okay, so we'll need, yep. Yes. As you write this code, remember you can treat individual element of an array exactly like the kind of data it stores. Inside a for loop, the event at index I can be accessed with notation event list I, right? So this is us iterating through an array. So if our array is 100 things long, right, 100 events long, this would, if I put 100 here, it will grab that 100th thing in the list and send it back to us. So if I count through it with a for loop, what I'm doing is looping through each item on that list and looking at it for something. So as you write your code, remember that you can treat an individual element of an array exactly like the data it stores. Inside the for loop, the event at index I can be accessed with the notation event list I, and the offset of the event can be accessed with event list I dot offset. Again, you are essentially treating the array as the array element as if it were the data it contains. Okay. And it's kind of giving us an example. Note, everything listed below is shown in the code animation above. Hey, this is what you're supposed to do. Inside the random button event handler, add a for loop that runs I from 0 to event list length to process over. All right, so inside the random event handler, event list length is going to give us the length of the full event list. So however many dots we've drawn. And we're looking at every single one of those because we're going to change them up. We're going to offset them. Okay, so I have what they do. Let's test. Huh. Oh, that's cool. So mine always gets smaller because my original dot size was 20 and I set it to 10. Let's delete, reset, random, oops, run. Now some even get bigger. Oh, I love it. That's awesome. Great. Let's keep going. Redraw the original. If you were able to get the working and understand what you did, congratulations. That was some serious programming. True. If not, take a moment to go back through the different components with a classmate. Most of the work we'll be doing for the rest of this lesson uses similar patterns, and you'll want to be comfortable with them as we add complexity to our app. The first thing we are going to do is create an original button that will redraw the image with the same circle radius you used before. The process will be nearly identical to the random button. All right, I just want to highlight some of what they're saying. This is complicated. So, when I am drawing right now, I'm holding down Shift. If I am holding down Shift and moving the mouse, if I'm moving the mouse across the canvas, and if the Shift key is being held down, this is happening. This append item. Append item is adding, we made this big list variable. It's an array. Event list. What's happening with append item is it's saying, okay, where's my list? Oh yeah, event list. Okay, well, on the end of this, add event. What's event? Event is data that carries the X value of my mouse, the Y value of my mouse. If any keys are pressed, everything that's going on basically is within event. So when I say save event, I'm creating a huge list of every tiny dot I draw, a history of it. And that way, the computer can recreate everything I've done with my mouse using that information. And that's what we do down here. We say, hey, that event list stuff, let's loop through I to the length of event list. So maybe I've drawn 10 dots. So event list.length would be 10. And then it goes through 10 times. Each time, it first says, we're starting at 0 because it already started at 0. So it grabs the very first dot we draw, event list, 0. So whatever event information was there, and grab the offset X from that event, and the Y. Grab X and Y from that event. Randomize the size, redraw that circle. Loop back around. Okay, we're now at 1. So the array at point 1, or the list item at point 1, is going to be the second circle we drew. Loop through, okay? Grab the event list at 1, which is the second circle. Grab the X, grab the Y data from that, from our event list data, and randomize the size. We hit the bottom again, we loop back. We're now at event list 2, which is our third piece of data because we started at 0. And this is the third event we saved up here, which means it is the third function or the third event we appended to this, which means it's the third circle. And we grab the circle, the X value of the mouse at that moment from the event list, I, which would be 2 right now, which is the third circle, and the Y value from the event list at the point 2, which is the third circle, and we redraw that circle of a random size. All right. That might make some crazy sense. It might not. We're going to get it eventually. The first thing we are going to do is create an original button that will redraw the image. The process will be nearly identical. In fact, copy the code. Got it. All right. Copy. Paste. I need to go create an original button. Do they show them doing that? They pick the third. That's not going to be my ID. Okay, and then, good. And I already have what I'm going to use with that. So not my random now, original. And then we're going to get rid of this random. And I think we would set it to... Did I use 5? I thought I used 20. I'm using 20. Okay, fine. I'll use 10. So we're setting it to our original value. So here's our for loop. It's going to loop through like I was saying a minute ago, redraw everything, but instead of a random side, it should be our original value, our original size, which I just set to 10. Let's try. I'm going to hold down shift. I'm going to let go. And then I'm going to hit randomize. And then original. That is so cool. Random, original. Delete. Let's draw more. Randomize. Original. Neat. Great. So ours is working. Let's keep going. All right, adjusting circle size. Among other pieces of information contained in each event parameter, and by that they mean this event thing here, which is grabbing our X, Y buttons every time any circle is drawn. All right, so contained in each event parameter are the values movement X and movement Y. These numbers tell us how far the X pixels in pixels the mouse moved since the last mouse event was triggered. Oh, that's cool. How far our mouse is moving. And can be used to measure the speed of the mouse. If the event is larger, the mouse is moving faster. If the movement is small, the mouse is moving slower. Let's use the mouse movement speed to make cool effect. When we draw with a real pen or brush, the line usually gets thin when making quick strokes and is wider and darker when making slower ones. We can generate this effect by using movement X and movement Y to calculate the radius of the circle. Since this calculation might be tricky, a smart thing to do would be to write a function that takes movement X and movement Y as parameters and returns a value that should be used as the radius. There are several ways to do this. One possible way is to write the function. Is provided on the right, which uses some arithmetic tricks. The function to write is actually only 3 lines of code, but is heavily commented to explain what we're doing. It makes use of the function called math.abs, absolute value, which returns the absolute value of a number. I just used that in a C++ program. Totally different. Feel free to use this or another method of converting movement X and movement Y to the radius. Woo! All right, let's see what this function does. I'm pointing at it, which you can't see. Dot radius change. So we have a change X parameter that we're going to give it. Change Y parameter. So those are original parameters. Let's see. The absolute value is used so that negative speeds are treated as positive. Adding them together provides a rough estimate of total speed. We want negative to be positive because if our mouse is going to the left, which would be a negative X value, we just need to know the speed of it. We don't care the direction. So variable, math absolute value, change of X plus the absolute value, change of Y. We want larger speeds to be given smaller radiuses. 1 is added so that even higher speeds the radius is 1. Oh, so if we go too fast, we'll still at least have a radius of 1. Variable output, 1 plus whatever 5 divided by speed. Return the output. Cool. Do this. Write a function like the one above that accepts 2 parameters, 1 movement X, 1 movement Y. Okay, here. I'm just going to kind of take a look at theirs and somewhat copy it. Okay. Okay, so we got that, right? Inside your mouse move event handler, set the radius of the circle to the value returned by your function, where the function takes event.moveX and event.moveY as input. For example, if you're using the function above, you would code circle, and then this is us calling the function. We're asking the computer, hey computer, run this dot radius function for the size of our circle. So up here, in Which function though? Is this the normal function? Yeah, okay. So up here in our mouse move, instead of having 10 apparently, we're gonna have, is it dot radius? We're gonna call dot radius. And then like they have, we're gonna use the most recent event. So hey, when we just clicked, or when our mouse, the most recent event is gonna be our mouse moving across the screen. So it's gonna take this current speed of our mouse moving and make the radius depending on that. 5 being the max for slow speed. Okay. Run the program to confirm that when drawing, the speed of the mouse affects the radius. The effect should look similar to. All right. Run. Ah! And if I'm going real slow, now let me speed it up. Cool. Awesome. And, oh yeah, original. Oh, that's really neat. Random. Original. Great. Let's keep going. Fix the original button. Our original button is now slightly broken because the effect it renders doesn't match up our new freeform drawing, which takes the movement of the mouse into account. It just draws fixed size circles. Let's fix original. Do this. In the event handle function for the original button, change the value used for the radius from fixed value to the same thing calculated for the freeform drawing. Okay. Since you wrote a function to do the calculation, it should be easy to call the code as well. The slight difference will be that you will be, the slight difference is that you will be looping over the array of events. Yes. All right, so we're going to be using I next to the event list because we're looping through all of our saved info. So it's no longer the current event, it's that event we appended, we added to our list, our event list array. So to get to it, to get to each one of them, we're looping through. And to loop through them, they're all kind of numbered. So we're using our loop to go to the first one, and then the second, and then the third, and that's what they're telling us. So the line of code that draws the circle will look like the one below. This line of code is certainly a mouthful, but it's basically the same line of code in the mouse move event handler. It just references the event in the list. Test your program to confirm that the original button creates the same effect, yes, as free drawing. Got it. So we need, instead of 10, I'm going to grab this. Copy. Let's shrink that. And paste. And now, instead of event, it's no longer an event. We're looking at our event list. We're looking at an array of that we made from our events. But random. Ah! Oh, perfect. Awesome. We got it. Let's keep going. Making spray paint. Awesome, yeah. The next effect we would like to create a spray paint effect. Instead of drawing a single dot for every location stored in the event, we'll draw many small dots randomly placed around each location. Oh, cool. We are going to start off just practicing drawing circle whose X and Y locations use offset X and offset Y with a small random value added. This makes the line of code to draw the circle look long, but hopefully it's easy to understand. So hey, draw a circle. We're going to grab some point in our event list, right? In our array of events. We're going to grab one of those events that we appended, maybe the third circle we drew. We're going to grab its X offset, and we're going to add a random number. We'll say this becomes 2. So we're just changing X by a little bit before we redraw it. We're just changing Y a little bit before we redraw it. Do this. Set the style of another button in design mode, give it the label spray paint, give it a descriptive ID, and attach a click event handler. Okay. BTN for button, it helps me keep track at least. Done. And an event handler, insert. Well, that one. Okay, copy the code from original. That's a long mess. Copy. Gonna get rid of their console log. Paste. Oh, what's this grumpy about? Expected a semicolon. Oh, did I miss one of them? Yep. All right. How about that? I'm going to hit Control Z for undo. Okay, it's no longer mad. Control Z. There we go. And we're just going to change the code of the circle. So offset plus okay, and it looks like we want this to be a 1. Let's see how it works. Huh. Okay, cool. Random. Spray paint. Huh. That's pretty cool. All right, I guess, looks like, yeah, we're ready to move on. Let's keep going. Making spray paint with nested loops. In order to make spray paint look more real, you will need to draw multiple dots randomly placed around the original XY locations. In order to do this, you will place one for loop inside of another, also known as nested loops. You already have the main loop, which visits every index in the event list. Yeah, in our array of events. We made that array right here, and then when the event is triggered, right, when our mouse is moved over the canvas area, we add to the very end of our event list the event. The event contains the XY location of the mouse and everything button being pressed. So that means every circle we draw, that data is slapped on the end of this big list of info. And then we can edit and change it and redraw it later using that information. So in order to do this, we'll place one for loop inside of another, also known as a nested loop. You already have the main loop, which visits every index in the event list. The inner loop should draw 5 circles whose X and Y locations use offset X and offset Y with a small random value added. We did that. Nested loops. When nesting a loop, it is important that you use different variables. Yes. Otherwise, the computer gets confused and writes over each other. To count your iterations. Look at the example at the right. These nested loops effectively say for every possible value in event list length, run a loop 5 times. So on every value, run this loop 5 times, right? So we're saying go to from the beginning to the end, from 0 to the end of our list, we're going to loop through and look at each point. Now, at each point, run this 5 times because this, I bet, we're going to use to draw 5 circles per point. Since I is used as the counter variable in the outer loop, we need to use a different counter variable in the inner for loop. or things will go haywire. Why? Because if both used I as the counter variable, the inner loop would keep changing the I, and the outer loop wouldn't count properly. This example uses j as an inner loop variable, but you could use anything that's not I. J is fairly common choice in computer science. I've seen C a lot too for count or N for number. Do this. Note, steps shown in the animation above. Oh, okay, let's do that then. But add a for loop inside the existing for loop so that the spray event handler. So mine's way down here. I'm gonna add another. I think we're moving this inside. Change it from I, like we were just talking about. I'll use J because that's what they did, and I guess I'm a follower. And 5 times 5. Okay, and it says it's supposed to work. See how theirs looks. Oh, that is cool. Okay, let's hit run. Ah! I love it. Let's keep going. All right, what do we got now? Relative indexes. I want to know what this button's going to be. Relative indexes. When looping over an array, we use a counter variable, typically I, to keep track of which index we're at. We can then access the contents at each index with syntax list I, right? So this is an array of info. List I would be whatever point we are accessing. So maybe I is a 0. I don't know. If we want, however, we could access the contents of the next elements as well. Since it's an index, it's just one more greater. For example, if we are currently focused on the element at index I, then list I plus 1, so maybe 2 is at index I plus 1, well, that's the index here, gives us access to the next element in the array. In other words, you can reference indexes relative to their your counter variable. So if I want the first point, and if I want to add my second and fourth point together for 100 different lists, I could do I and set I to count that second element each time, and then I plus 2. So I would say array num, and then in the brackets have I plus array num I plus 2. You can add to it to access other parts. We are going to use relative indexing to create our final effect, which will look sort of like etching of the image. The idea is simple. For every XY location in the event list, draw a straight line between that location and the location stored 10 spots down the array. You will use the line command to draw a line connecting these points. Awesome. Read the documentation for the line. Set the style of the final button in design mode. Give it the label etch, give it a descriptive ID, and attach an event. Attach a click event handler. Let's see what theirs looks like. They use the standard color. Okay. Etch btn. Etch. And then we need an event handler. Okay. So we have in our event, call clear canvas. I'm going to get rid of this console log. Create a for loop that counts from 0 to event list length minus 10. So that's, I know why we're doing that. And that's because we're going to use plus 10 for the etching. So if we go to the last one, there's nothing beyond it, so there's nothing to etch to. So 0 to Use line to draw a line between X and Y locations of event I and I plus 10. Oh, what about adding 10 each time? We're not going to do that? Okay. So I'm just adding in what they have here, because we're iterating through an event list. Okay, now I need to set stroke color and or a set stroke width inside the event handler, so inside this handler, to make the line visible. Okay. So set stroke color or, yep, set stroke color. And then set stroke width. We'll try 3. Since we set the stroke color to transparent at the beginning, run the app to confirm. All right. Let's test it out. I'm going to hit Shift. Yeah. Okay. And then, I don't know, random. Spray paint. Etch. Whoa. Ah. What's theirs look like, though? That's so cool. Let's try it again. No. I want to go back. All right, let's try one more time. Their handwriting is much nicer than mine. That's supposed to be high. Random. Spray paint. Original. Etch. Fancy. That's super cool. All right. Let's keep going. Oh, create your own effect. You've seen several ways that you can process our array or event list in order to create different effects. Now it's time to make your own. Extend the functionality of one of your effects you just created to create an entirely new one. What else? Oh, they didn't even do color yet. What else would you do with the information you've stored in your array? How else might you combine programming tools you developed, extend the functionality of one of your effects, create an entirely new one of your own? Awesome. I have a bunch of ideas for this. Okay. I definitely want to add some random color elements to this. Let's see what we have here. Spray paint. Spray paint needs color. It's also way too small. Just so we can see it, I'm going to hit enter here. It's all still together because there's a comma there. At least I hope it is. Yep. And then spray. Yeah. Okay. So, oh, I also want to change this. I want this to be fill colors 3 maybe. Yeah, that's a bit better. Okay. Spray paint needs to be random colors. That is for certain. So, and I want to do it with each dot. Let's go nuts. Number, event, circle. Where's circle at? Okay, where's fill? I'm going to fill it a different color each time. And then for, yeah, that's what we want. Red, green, blue. We want not that. That. And then our colors are between 0 and 255 for RGB colors and computers. And then I'm just going to copy paste. Okay, I want to try this out. Reset, run. Ah, much, much better. Okay, that makes so much more sense to me. What is their size here? Oh, no. I'm gonna take a random. That size is too small for me. I'm gonna do 1. Yeah, 1 to 2, I guess. Is that? And then I'm gonna offset it to make up for the larger number there. 4. Reset, run. I don't like the speed thing. I use a mouse very quickly. I like that. All right, now I need this though set. Spray paint's kind of more splattery looking. I'm gonna set all of this to 80%, to a little bit transparent, I guess is how I should say that. And then I need, where's the mouse speed? Speed. At least 2. Random. Spray paint. I love the spray paint. I'm gonna offset it more though. So my Y offset. Oh, I didn't do a big Y offset. So -4, I was thinking to 4. I could do 5. Whoa. Uh-oh, what did I do wrong? So, our glitch that we've been working on, I'm gonna draw something cool, yay! And then, if I do spray paint, cool, right? Etch, now spray paint, but-oh. I should set, way down here, set stroke color black, set stroke width. I need to put it back to its original. So I'm gonna grab these two and copy them. And then right here, before the end of this function, I'm gonna paste. And then since my spray paint now, I've edited it to change colors, I'm going to paste that too. Okay? Show blocks. Let me give this a shot. I'm hoping this fixes it. It's driving me. Oh, what happened to... Oh. Ta-da! Random. Etch. Spray. Yay! Etch. Spray. Original. Awesome. So that's my thought of what I could do. Obviously, I think we've hit all the components. Yep. All right. What I'm gonna do now is, and I know you're jealous of my app, so I gotta share it, and that's what I'm gonna do. I'm gonna hit share. You should definitely. Oh, where's my? I like when it has a picture. Rah, yeah, da. Those are my drawing sounds. Spray paint. I'm gonna hit share and publish. Yes. Oh, I didn't copy it though. And you should definitely share yours. All right. I'll put this in the description. Do not copy my application. You need to create your own thing. That is plagiarism. It's really easy to find this on the web, right? Teachers can search for it as well. But what's great about programming is the community and the ability to share applications, programs, ideas, thoughts, and build on them, improve them, make them better, throw them out because they're junk and make your own version, right? So take a look, see what I did, and make something super cool. In the comments, post yours. I really would love to see all the original stuff you create. So yeah, go build stuff and, well, share it.